Okay, let's solve a problem that gets quite a bit more complicated here. And so we'll just do this the way we have been doing it. Let's read that problem carefully. A metal ball with a mass of 2 kilograms is thrown and has an energy of 2,500 joules. Now I know that that's likely kinetic energy. Um, we're not dropping it, but it doesn't really matter. Once we know energy, usually most of these things get converted back and forth. So the question is, how fast is the ball going? When I see how fast, I'm thinking velocity equals question mark. So I'm looking for a velocity here, and my final answer better end up in meters per second. And so we'll double check to make sure that that's what we get. Well, how do we solve this? Well, let's write down what we have. We know the mass of this ball is 2 kilograms, and we know the energy is 2,500 joules. Okay, not too bad. I know kinetic energy formula is energy equals 1/2 mv squared. Now, instead of plugging into this equation here and then solving for a v that's squared, I like to do this ahead of time. So let's go down in the corner here and let's see if we can get a nice clean equation to work with up here instead. So if energy is equal to 1/2 mv squared, let's go ahead and solve it for v. So I'm going to take it times 2 on both sides, and I get 2e equals mv squared, because if I take it times 2 here, times 2 here, these things cancel. I'll divide by m on both sides, and then I end up with the m's canceling. Now, if you'll indulge me, I'm just going to flip this real quick and get v squared equals 2e over m, and all I did was just flip this over. If a is equal to b, then b is equal to a. Now, I don't want the velocity squared for my problem. I want to know what the velocity is. So in order to get v, I'm going to have to square root this side, which means I have to square root that side. So I'm going to end up on this side with v equals the square root of 2 times e over m. And you can write that down and keep that handy formula. Anytime you have kinetic energy and you want to solve for velocity, you can use this formula instead of plugging in and solving here. So I'm going to go ahead and do this problem. V equals the square root of 2 times e over m. And now we can just simply plug our numbers in and hopefully we get the correct answer here. So we're going to have 2 times 2,500 joules all over 2 kilograms. Now that worked out pretty slick because these just happen to cancel. So these 2's are going to cancel. And I'm going to end up with the square root of 2,500 joules per kilogram. All right. The square root of 2,500, if you punch it into your calculator, is going to end up being 50. But how do I get the square root of joules over kilograms? That's a really odd unit, it seems like. So let's again kind of do some work in the margin here and see if we can work out the units to figure out if we're going to get this right. So something else I pointed out to you earlier was that a joule is a kilogram meter per second squared. So let's go down here and let's just substitute in. Instead of joule, we're going to write kilogram meter squared per second squared. So we're going to have a kilogram meter squared per second squared divided by kilograms. Well, now we can see this looks like it's going to work out pretty slick. We're going to cancel our kilograms, and we're going to end up with the unit of the square root of meters squared divided by second squared, which is really just equal to meters per second. Worked out really slick. The square root of the joules per kilogram, as we worked out here, is meters per second. We were looking for a velocity, so our formula worked out, and our answer is that that ball was going 50 meters per second.